This mouse may be small in stature, but it represents a big milestone in stem cell research. What few believed could happen has happened. Chinese researchers have created life from what began as a skin cell. This and other recent stem cell discoveries have rocked the scientific world.
If you'd asked 10 of the top scientists in the world 5 years ago, would Yamanaka's experiment work? They would have said no, absolutely not.
This was like a bolt from the blue. It absolutely threw everyone for six.
Here we explore the latest triumphs in stem cell research and why that long-awaited cure for our most serious diseases may be finally within our reach. Embryonic stem cells have long been hailed as having the greatest potential of all stem cells.
Embryonic stem cells are the only cells that have been proven to develop into every kind of cell in the human body.
This quality is known as pluripotency. As their name suggests, embryonic stem cells are harvested from human embryos. And this presents an ethical dilemma. An alternative is adult stem cells, but they lack pluripotency.
Adult stem cells are very constrained, very confined. They usually will only differentiate to give the tissue from which they've come.
But an extraordinary discovery by Japanese scientists may have solved this dilemma. In a feat that will be talked about for years to come, Professor Yamanaka took ordinary skin and reprogrammed it to behave just like embryonic stem cells.
人でもできるんだっていうのが分かった時はびっくりしたっていう方が強かったです。
When Yamanaka presented this information, this new discovery, to a group of people at a big meeting that I was at, an international stem cell meeting, he was treated like a rock star. Everybody was so flabbergasted with what he was talking about.
Injecting just 4 genes into the adult skin cells was all it took to catapult them back to their embryonic state.
They painstakingly went gene by gene and combination by combination to try and discover what set of genes would be able to reprogram the cells.
Yamanaka finally unveiled induced pluripotent stem cells, or iPS cells. They appeared to have all the promise of embryonic stem cells, but with one crucial difference. Embryos were not sacrificed in the process. These iPS cells hold promise for people like Carrie Beetham. She suffers from a tragic degenerative nerve condition called Friedreich's ataxia.
You get shaky hands and a little bit off balance. And then over the years it gets worse and worse, and eventually organs start failing and your heart eventually gives out. My brother
At 33, Carrie is now wheelchair bound.
Me. I can still feel myself walking. Remember what it felt like, what it was like to dance.
Her sister Vali quit her job and now dedicates her life to raising funds for this type of research.
Stem cell research has really allowed us to be in there with a real hope for a treatment and a cure. And we've got brilliant researchers here in Melbourne working at the moment to do that.
Carrie has had her own skin transformed into iPS cells. It's just remarkable to consider that this could be the springboard for a future therapy.
Firstly, we will take Carrie's skin cells, genetically manipulate them to correct the mutations that they carry, and then push them into the cell types that are affected in this disease. And the ultimate long-term aim would be that you could even transplant it into the patient.
And the beauty of this therapy is that it won't be rejected by her immune system.
Unlike human embryonic stem cells, which will come from an unidentified donor, if the cells themselves can be obtained from an individual themselves, then there is very little or no chance of rejection.
本当に何て言いますか、オーダーメイド医療、ご自身のための細胞を作ってその方に戻すというような治療が本当に夢ではなくなったと。
I have great faith in what the scientists are doing at the moment, and I believe that we will get there.
I think it's early days yet, and we mustn't try to rush it. We're looking at something that's going to take 3, 5, 7 years to understand.
In the past, there have been concerns that iPS cells could cause cancer. But new developments are making them safer.
When the genes are introduced, they can actually disrupt existing genes, such as cancer-causing genes, present in the cell. But what we've now learned is that you don't need to use genes themselves. You can actually use the proteins that the genes encode.
Using proteins instead of genes to reprogram cells is safer and less likely to cause tumours. Even after the extraordinary discovery of iPS cells, there were lingering doubts about whether they really had the true potential of embryonic stem cells. Well, it didn't take long for the Chinese to silence the skeptics. Professors Zheng and Zhou are the first in the world to prove that iPS cells have the potential to create new life.
We were very excited that we generate live beings from iPS cells. Many people suspect it's not doable.
Meet Tiny, the first mouse ever to be cloned from skin. An exact replica of the mouse whose skin it was taken from.
I believe it's a milestone for not only for cloning, even for fundamental research.
They began by taking skin cells from a mouse tail and converted them to iPS cells using Yamanaka's method. These were injected into the shell of a mouse embryo, which would otherwise have been incapable of developing into anything on its own.
When we inject the iPS cells into the embryo, whatever comes out to be the live animal would have to be coming from the iPS cells.
This is an incredibly difficult technique. Only a few labs in the world are capable of such a procedure.
We got success in so far 4 different cell lines with different genetic backgrounds so that we know it's real, it's not contamination or any kind of other reasons.
The mice even proved to be fertile. Up until now, they've bred 3 generations. This was a prime opportunity for scientists to see whether their concerns about stem cells causing cancer were justified. The result? Well, mice did not develop tumours, but there were other problems they wouldn't disclose.
At this point, we're not sure, and this is under investigation currently.
These discoveries are likely to reopen old ethical debates about reproductive cloning. But the question everyone wants answered is, now that we can use skin to create mice, can we do the same for humans?
This is not the focus of our study. What we're interested is to create some human organs that we can use as a regenerative medicine.
At this stage, we don't know whether it would be possible to clone a human. Any attempt to clone a human in Australia is illegal. I cannot imagine that any responsible scientist in any responsible country would attempt such an experiment.